Cool, okay. All right, let me get this going. Okay, cool, okay. We are gonna be, this is gonna seem like almost a college lecture compared to what we just did. So I apologize for that. I know I'm the only thing between you and the break, but bear with me. I hope this is gonna be good. So this is learning and managing code with code notebooks. So how many out there have used Jupyter Notebooks? Oh, quite a few, good. Okay, so that's part of code notebooks, but what we're going to be looking at today is some new extensions in Visual Studio Code that allow us to create notebooks in all kinds of languages. So we're going to be looking at Node, but you can create them in Go, you can create them in Rust, and it's great for learning, it's great for saving, and that's kind of what we're going to get into. Before we do, I'm going to tell you a little bit about myself, because I have been programming, getting paid for it since 1982. So I'm kind of an odd person on the demographic. I saw the latest Stack Overflow, and I'm about 0.2%. But I love coding, and I think these notebooks are one really great way to experiment with it. So my current position, I am a curriculum program manager at Cloudinary. And what that means is I stay in touch with our R&D. We have like some amazing people creating new services for managing and manipulating media. I create use case code out of it, and then we put together webinars and training and talk to people. So I'm still doing a lot of coding, but what I'm showing here in my circle is I haven't always been in developer education. I started out, if you knew where I started as a computer operator. I don't even think you people know what that is. You know, if you remember on the old Star Trek where people changed tapes, that's what I did when I started out. So I've been doing this a long time, and I have pivoted a few times, went from databases into web applications and now developer education. And I wanted to just share a quick thing, because I've noticed a lot of these workshops and talks, people will ask you to raise your hand and say, how long have you been doing JavaScript? And like you can see, I've been doing whatever I've been doing for a long time. And still, I know about that imposter syndrome. It's real. I mean, even vice presidents will tell you they have companies, will tell you they get it. It's actually a very energizing thing. I have spent most of my career kind of riding the crest of things and really enjoying it. A lot of times not knowing what the heck I was doing and just playing around. And you know, I kind of look for that now. So education is a good place to do that, because I get questions from people that I don't know the answer to, and then it's a really motivating thing for me. So anyway, just want to throw that out there. It's good to not know things. It's energizing, and then you can find out the answer, and you get that dopamine effect, and it's a wonderful world. So anyway, that's me. I'm going to spend a little bit of time here setting the context for notebooks. Like, what are notebooks? We all know, but let's just take a look, because historically, people have been creating notebooks. I'm only going back here to like the 1600s here. This is Leonardo da Vinci's. Of course, you've heard about his notebooks. This is a picture taken from Codex Atlanticus, 1,119 leaves of paper. You can go to this link and find, they've put all his notebooks online in a scanned form. And I think one thing to start looking at here is what's going on in it. And you know, he's got lots of pictures, he's drawing, he's writing text, you know, he's talking about it, he's putting it into his language. And in fact, he's the guy who would write, you know, mirror text, which a lot of people kind of said, well, is he trying to hide what he's doing? And it turns out, no, he was actually left-handed, and if he wrote left to right, it smudged it all up. So he was really trying to keep his text clear. And I think these are kind of a couple things to start thinking about with notebooks. Next, physicists. So we're all thankful to Isaac Newton, who's made this line about working on the shoulders of giants and creating the first kind of thought of open source. So the idea that you can take other people's work and build on it. And here he's actually developing optics. And they eventually became the Newton telescope. People still use Newtonian telescopes. So again, he's writing text, he's writing pictures. You can't even always read what he's writing, but sometimes he wrote in Latin and Greek, but never with the sense of obfuscation, more with just, trying to get his notes down, trying to work through things. He even has notebooks that say not fit for print, so he's really knowing that he's doing this to help himself develop something. Chemist here, Marie Curie, so she's creating, notes for experiments. Now her stuff is radioactive for 1,500 years, so luckily we can scan it and look at it online, but a very intense kind of work that she was doing. Geneticists, so Gregor Mendel, if you've studied, genetics, kind of the founder of genetics, creating rules for, the way that heredity works, recessiveness and dominance, by counting P's, by counting yellow versus green, wrinkled versus smooth, by creating notebooks full of data and going back and analyzing it. And then artists. So artists create wonderful notebooks, and many of them you can find them online or purchase them. This is Jean-Michel Basquiat. The more I paint, the more I like everything, and he's got some really fun notebooks. He's got friends' phone numbers in there, and then how an eardrum works. And he was an artist out of Brooklyn who kind of got into art through graffiti art during the late 70s, when New York City was kind of going broke and there was a lot of not so great stuff going on. And they came in and started putting graffiti, and it actually made people a lot happier. And now he is considered one of America's great fine artists. But again, you see notes, you see pictures. I think this combination is what we're doing when we're creating notebooks. So, computer programmer notebooks. Does anyone here keep notebooks? I keep them, but this is kind of a nice picture of notebooks. This is from Pexels. It's where you can get free images. My notebooks aren't so neat. They're kind of just doodles, and they help me a lot. I can work things out. I can then take my ideas and go code them. But they are not shareable, really, and I can't even find things in them. They're not indexed. They're just something I do to help me think through problems. So my question is, can we digitize these notebooks? And when I say this, I'm not saying, let's stop doing these hand-doodly type of notebooks, because I think those are really valuable. That's where you really allow yourself to just kind of think of all different things and not worry about it being typed. But there is a point where you do want to share what you're doing. And because we're writing code, because we're creating digital output, it makes sense that we might want to digitize these. Before I talk about what we're really going to learn about, the what, how of these Visual Studio Code extensions that let us write code notebooks, I just want to bring up literate programming. It's kind of important in this context. So if you've ever worked through problems in the art of computer programming, Donald Knuth, then you know that he is just a guy that loves code. And if you haven't done that, you can go on YouTube, you can watch him talk about it. And he's just, for him, code is like literature. I mean, it's not just the thing that gives you the output from the machine. It's actually the actual stuff that you type in and how it's organized. But he came up in '84 with a language he called web. So this was before the web. And the web language that he had, the purpose was to make something that humans could understand, because we all get, especially us, this group like this, we're used to looking at code and just kind of taking it for granted that it's going to look the way it does. We write it, though, for the machine. There's certain order for making it easy to parse, making it easy to just basically sequence your way through. But for what we're doing is we're usually solving a problem or creating something for humans, and so it makes sense that we should talk about it that way. And this is not just comments. I mean, comments in code, they kind of have a history of their own. I think a lot of people, if you're get a job at a company and you have well-commented code, it's great. You're going to be able to fix all their bugs for them. But a lot of times comments are incomplete, out of date, not maintained. The code moves on, but the comment stays. So this has nothing to do with comments. He's talking about the fact that a lot of code, when you look at it, what you're going to see is like the error handling, the iterations, a lot of things that when you look at it, it's not going to register for you, who he believed, and I think it's true too, we tend to think in a more tree-like structure. We're not, just constantly poking through a sequence of things. We have our thoughts, they connect to other thoughts, and so on. When we have a conversation, somebody says something, it triggers something new for us to say. So we're more like working our way through like a web. So his idea, if you could see in the bottom picture, was that you would write a program where you have these kind of brackets, these indents, where you would put some English, if it was our language or natural language, and then you would put a little bit of code, and then wherever there were these braces, it would refer to another section of the document where you would define that code, and you would write about it. And then at the end of the day, you'd have this document that kind of mixed English and in this case, Pascal. And you'd run it through these two processes, which he called tangle and weave. And tangle would go grab all the code, link it together, put out some Pascal source code, which you could compile to binary, and that would be what you'd run. And then he had his own text formatting language called text. And so he would grab all the English that was in there and put it through text processing and output something called DVI, which would be like a PDF. So this was his thinking way back then, and people are still working on this and implementing it. As I go into Code Notebooks, I'm not going to be suggesting this as a solution, but I think it's kind of a good context for where we're at now to think about that. So in case some of you, because I know not everybody's been coding since Fortran 77, which that was the first language I learned on, but code, even our code can get difficult to read, but you can see this code at the time that Knuth was writing about literate programming, this is what people were looking at. So this was called spaghetti code because, it looks like spaghetti, and there were impossible things to try to figure out, because the go-to statement which was how you created iteration, how you got out of something that you didn't want to be in, if you were doing some checking, some data checking. It just was really hard. I mean, you couldn't look at that and really tell what's going on. So this is actually the same program as this. Here he's wanting to print the first 1,000 prime numbers. Same thing, this is a complete program, finished, ready to run. But most people are going to look at that, and this kind of stuff was actually, I think, a barrier to entry for people wanting to go into code. I mean, they'd look at that. Of course, Fortran was known for being scientific, mathematical. That I am not mathematical, that's impossible. I just can't possibly spend the time to work through that. And they're right. But here you've seen what GoTo can do to code. And he actually, using Pascal, was kind of the next level after they made a rule in late 70s, no more GoTo in languages. They got into structural programming, which was Pascal. So 10 years later, 10 years ago, maybe many years later from literate programming, data scientists started creating Jupyter Notebooks. And this QR code takes you to a notebook that I created, and you can pull it up. It's in GitHub. And it's very nice. Jupyter Notebooks are really the epitome of this kind of work because they allow you to do some markdown, and they let you then pull in libraries, run code, generate these beautiful charts. And this is great because data scientists are storytellers. They are looking to isolate variables, find the relationships between them, and make predictions. And in this particular example, the IRIS data set is a very old, famous kind of example for data scientists, or if you're learning data science. They compiled this data on irises. They measured the sepals and the petals, which frankly I can't really tell the difference, but they measured them. They were able to come up with a way to predict. They could tell the species based on those measurements, and it was all through this kind of analysis of variance, and has now been, you can put that into a code notebook. So that's been going on for over a decade, and these are really great. And if you go out and look at this on GitHub, even though it's not an MD file, it's not a markdown file, they have a way that they convert it to markdown, and so even you can share it right on GitHub, and great for collaboration. Anyway, so these are really where we're at. But why are notebooks so important now, like for developers? Like, why would we want to get into that? I mean, we got plenty of ways to store our code, and we have, you know, really great IDEs where they can get indexed and we can find stuff. So why think about doing code notebooks with this? This is me reflecting on my entire career. I don't expect you to, but I think what my ultimate point here is back, you know, when pretty much the 50s were kind of the beginning of a lot of serious computing, and then into the 60s, 70s, even when I learned in the 80s, spaghetti code, okay? So you just have these massive programs, I mean, Fortran programs, even programs, I did programming on cards. They were huge. I mean, you'd have like boxes of cards. No more, okay, that's the old way. We have kind of marched our way through that whole era of into structured programming, where we would have like a whole bunch of functions, but they would each be sort of focused. And then we went into object-oriented programming, where we actually can encapsulate our functions and link them to data. You know, we could have our data and our functions together. And then we got the web. So now we've got this whole set of protocols for communication, and especially with JavaScript. I mean, we've seen amazing things happen with JavaScript. When I started, you know, we were basically just using it to see if you entered the same thing for your password twice. That was that's all we did with it. Then we got, you know, XHR, we got Ajax. We can now talk to servers, and we got the internet. I mean, originally we were just talking with these weird protocols, remote procedure protocols. Now we just talk through HTTP, and we have Lambda functions, and we can, you know, you can go and create one right now and for free have it hosted, Vercel, Netlify, serverless. So we have right now, we're in a position where with the cloud and with these kind of Lambda functions, we can be responsible for creating just a very small function. It is going to be linked with other functions through HTTP, so we don't have to like bundle up all our functions in one big thing. That could be done through like a flow, you know, like you probably started seeing flows where you can hook together different services through notification URLs and such. So we're really in a great position to now take these functions and really explain them, like get them in a notebook, explain what they do, not have to reinvent them every time. A lot of these Lambda functions I've seen are very similar. You know, you're doing basically the same thing. You're calling an API, and you're going to do something with the data. This is just, I wanted to make a cartoon out of this, but I wasn't very good at that. But basically, back when I started, we would calculate pi and then output it. Today, we're okay with using a constant. And you know, if that sounds funny, I mean, maybe it's not funny to you. I mean, to me, it's like we got so much computation going on. There's so much in our world now that relies on computation that we don't need to calculate pi anymore. We're good with going with a constant. And I think that's really important to think about is the computational cycles that are going on, and the fact that we're using the cloud because we can't really afford to have a little data center with a computer operator. You know, we're in a kind of a different world, and our languages reflect that, and I think how we deal with code is also reflective. So now to get into the notebooks for developers with JavaScript. How to do it. So very easy. You go out to the VS Code Extensions marketplace, and you search for notebooks, and then you find the notebook that fits your language or project. In my case here, I'm pulling in Node. I mean, I have an example there with Python. And I actually do pull in the Jupyter Notebook tools because they sort of enhance the code notebook even in other languages. But you grab your extension, you install it just like any other extension. I'm not assuming that everybody uses VS Code, but even if you don't use it, it's very accessible. And if you wanted to try this out, it's free. So what does it look like? This is a code that takes you to a repository I created for this talk where I have a couple of samples. And so what you'd see out there are files that have an NNB extension. So they don't use the MD extension like Markdown. They have each, you kind of, for people creating these extensions, they pick their own extension. But if I go out and look at this, so I've been an instructor. I've taught, before I worked for Cloudinary, at I've taught at boot camp, I've taught at university. This is one of the lessons that's really hard to teach, error handling in JavaScript. And so I thought I'd make a code notebook on it and see how I could capture some of the difficulties. And I actually got inspiration, if you go back here, this QR code, a guy, I've got his link there, wrote a really good article about that. It's called The Good, the Bad, and the Ugly. And so I wanted to kind of work through that and just run it through this notebook. So it's very simple to do. I mean, it's just like writing, when you're in here, you'll see you get a code plus and a markdown. So you can just add code where you want and add markdown. Now I've added the node extension, and then you come over here and you pick your kernel. So you might have different versions of Node. You can actually pick that. And if you were in another language, you'd be having that same option. But beyond that, that's pretty much the only setup to get this going. Then you just put your markdown, and here again, you can use English, full sentences. You can put pictures in there if you want. Anything you can do in Markdown, anything you can do in HTML, you can put in your Markdown here. And then you just paste your code in there. So we're doing the good handler where we return something here, the error message. The bad handler where we just return null, like, I had a problem, I'm done with it. But bad handler, leads to unresolved errors. And then testing it with some callbacks. So a callback that throws an error, a callback that just returns something friendly. And then you can see I've actually already run this. I can run it again if I want. I can clear the output and just run all. And basically, I get my output. And you're going to see in some of my examples here, sometimes the output is actually more important to remember to look at than the code you wrote. Because if you're working in the cloud and you're hooking together different services, that output from one service is probably going to be the data structure that provides the input for the next service. So a lot of times the output's really important. And in this case, I create the ugly handler. And the ugly handler is going to throw a new exception, which is a really good, that's kind of standard in most backend languages, and it's going to pick up the stack for you. In JavaScript, you will not get that stack automatically. So you won't get the full stack. But if you want to bubble your errors up like you would, you can create this specified error, which is just going to be a function that encapsulates, the error the message that you're throwing, or something. You can, if there's no message, just make up a message, and you can add the stack to it, so that when you throw this specified error as opposed to just throw error, you're going to actually capture any errors that came before you. So this is a really good lesson. And then I can see in the output here that I am picking up my problem that occurred prior to this particular function that I'm running. So I am able to get the stack. And if you run through each of these separately, like if I was teaching you and I said, OK, I want you to go study these good, bad, and ugly handlers, and then make some summary of it, reflect on what did you learn about it, you can add that to your code notebook too. So the good, if I return a value, I'm going to do okay. It's going to work for me if I have an error or not. Bad, I'm just going to end up eating errors. Silent, fail, not good. And then ugly, with my specified error, I'm going to be capturing the full stack trace. So I think it's a good teaching thing. And that is one example that I would use it for if I was, and I might use it for it. I kind of got into this because of my current job and where I was looking for kind of ways to present material. Here's kind of a picture of what we just said. Got the good handler, the bad handler, our specified handler that captures the stack. And so if we throw that, we're going to keep it attaching to any future errors. The response is important as the code, and I see that over and over. So how to create JavaScript charts server-side. So this is another thing I wanted to do was, I've done client-side charting. I've created dashboards and things. And there was a library called HiCharts that made it really easy. You just pull your data in, add whatever options. You can create charts very quickly. But I wanted to do it server-side. I want to use Node. How am I going to do that? So I actually found a library that does HiChart server export. But when I started playing around with it, it was like it just didn't work right. It said, well, you have to accept the license. And that's because their front-end stuff is licensed. So in order to use this package, they wanted you to accept that license. But I couldn't figure out how to do it. It turned out you had to CD down into Node modules and then run their build script and then say, yes, I accept. So that was a good thing. This is another good reason you might want to have a code notebook is sometimes you have to do some funny little things to get your stuff working. And I don't want to have to come back to this in a year or 6 months or whatever and not remember what that was. So I can just take a few notes about what I did to get this thing running by running that build script. And then it's really simple to get this running in here. So once I tell myself that, I can just stick the code for this server-side exporter in. It's going to actually create a PNG file for me. So let's see, where did I do that? It actually is showing up down here. So I put it into some HTML source and just displayed it right down here. But the output chart, there it is. Yeah, so this thing on server side creates a chart. So if you happen to be in a situation where you don't want to run all these chart creation through your client, you can just generate stuff on the server and push it out as images. So this was another kind of good use of these code notebooks. And then, now I get into Cloudinary. So this is just looking at charts. Cloudinary, where I work. So we teach a lot of classes using the Node SDK. We have about 12 SDKs, but people do like learning through Node, so lots of coursework there. And a lot of times I am repurposing stuff for just a different slant on the same material. So config, upload, deliver, and webhooks are things that are chunks of code that I might use over and over again. I don't want to memorize anything, so I can just stick them in a notebook and, for example, config. And I could share this too with students, and just basically reminds you if you're going to get Cloudinary going, you need to initialize npm, install cloudinary.env, put your credentials in your .env file, and then you can verify by printing out your cloud name. So this is nice. I can just have that all ready to go. And then upload, this is something that we have to use a lot. This is how we get our, this is how we're going to get our images and video up into the cloud. And one of the neat things here about this one is that I can see the output, so the response here. And like I said, this is many times, once I've uploaded, I want to take information out of that response to do the next thing, like to go moderate it, just find out if there's, any pornography or violence in it. I can grab some information here and run it through a moderator. And so I can just keep an example of this. It gives me the kind of data structure. I can remember really easily what are all of the parameters that I get in the response. Deliver. So once you've got it uploaded, the next thing we're going to do is make a request, through the browser, through a web page, and get it on a CDN and have it sent out to the web page or the device. So here I'm capturing how do I create various types of URLs, because basically all we're doing with delivery, creating a URL and calling on it. So whether it's video or an image, or if I want to add an effect, so in this one I've got a cartoonified fish, or if I want to optimize it, we all know we need to get our images smaller to get our pages loaded and have good SEO and everything. Now I got this all kind of captured here in the one notebook page. And, this is the notebook. Yeah, I can't tell the difference between being in the notebook and being in my slide. Then webhooks, again, this is where we're connecting different services. So in this case, and I will show this one in code. We have time here. So this is where we're pulling in often other services. So here's SendGrid, so one of the communication services. This one's to send email. So after I process some giant video and I want to get notified that all that processing is done, I can just set up a SendGrid call. And now with it in this notebook, it's all indexed in VS Code. It's on GitHub. I can just come out here and grab this code. I don't have to remember all the details of when I got it working. And here's another one, Google Moderation. So if I wanted to moderate video or images, so basically we have some AI in Cloudinary, that AI add-ons that allow us to run our media through these things like moderation. It puts them into rejected and accepted queues, and once they're in there, I might need to go process those queues, maybe delete the rejected stuff, and maybe make the approved stuff publicly available. So all that code that it's kind of like very focused. It's, I might tweak it a little given the specific case, but it's all here. And even if like I'm talking to a customer, I can share one of these with them. Potentially. So what's next? And here I'm getting to the end of the talk. So there is a VS Code Notebook API, and that's the link to it. If you looked at my code, the link that I shared for these NMB files, what you're going to see is serialized JSON. So this is what I see too. This is kind of an incomplete experience. We want it to look nice like the Python notebooks, the Jupyter notebooks. And what they're doing is using an NB convert. So they are converting their notebook to markdown in a step that currently I don't see being done here. So I'm looking at this. I just started looking at this a couple of months ago, back maybe spring. Anyway, this is a great potential project to kind of round out these code notebooks. So they do a nice job rendering it inside Visual Studio, but to get it rendering as Markdown also online. So that's kind of where I leave it. And you can get me on LinkedIn, Rebecca Peltz. And also I'm hanging out at the Cloudinary table a little bit. So did I finish in time? I think I did. Any questions? Any comments? Thank you. Thank you. Appreciate it. You guys are nice.